In this video, we finish up the schematic for the register module. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
The first order of business is to go create the 74AHC 138 demultiplexer. It's a 3 to 8 line demultiplexer. And I'm going to do that as a copy of the 74LS 138, except I'm going to drop it into my own personal library. It's a simple copy. I grab the data sheet and update that as well. Next, I'm going to use the 74AHC 138 demultiplexer and the schematic to help with the input signals. I'm going to copy power and ground off the adjacent IC, not AC, IC, just to make sure that I get those hooked up. Now recall the most significant bit of that demultiplexer is going to be tied low all the time. And then I want to be able to output as well, so I need to hook up the two control lines that are active low and one control line that's active high. Now here's where I realize that I need an extra line driver, or actually the second line driver, in order to support all the outputs that I need. So I start by making room for that, and then I'm going to copy and paste the existing line driver just to make a copy of it, and then I will work on hooking up all of those controls later. I still don't have everything quite cleaned up with the line driver yet. I take care of that later in the video. First, I remove the extra LEDs and resistors off the schematic, and then I mark the pins on the IC as not hooked up in order to prevent there from being issues when I run the error check or the rules check later. That'll be in the next video. While I'm at it, I'm going to go ahead and mark the unused output pins on the demultiplexer, the 74AHC 138 IC. Next, I go grab the two input signals I need to demultiplex. And I realize at that point, when I go to change the direction of that signal for the input into the demultiplexer, that I've got the signal direction incorrect on the interconnect. So I now have to go fix that first. While I'm at it, I'm going to go ahead and change the main bus to be both input and output bidirectional. Now, back to the two inputs that need to be demultiplexed. I have to make a little bit of room for those. And of course, now I've got to grab the second input that I neglected to get before. And now that it's set to be an output, I got to change it back to be an input. With that done, I can drag wires over to the line driver to indicate the output of those three signals. And of course the unused inputs all need to be brought low. Now here's where I realize that I don't have my inputs actually sequenced correctly. I start by pulling the byte swap assert down, or actually up, to the correct position on the input block. And then I fill in the last two inputs on that line driver. Those are the AND latch signal and the byte swapped assert onto the main bus. Once again, on the other line driver, I take the unused inputs and make sure that they are tied low. And then I need to also sort out the sequence of the inputs for that line driver. So I get those taken care of. And they get copied as well for the inputs into the line driver. And of course, changed from output to input. Finally, some cleanup so things don't look quite so crowded. Okay, we're going to need a bigger boat. And thanks to everybody that caught that reference. So I changed the page size from 11 by 17 to 17 by 22, which gives me a lot more real estate. And so some cleanup is in order after doing that to give me a little bit more room and make things look not quite so crowded. So here we go. The next step here is to create the remaining two ICs that I need to use. That's the 74 AHC 574. That's the 8-bit register. And then the 74 AHC 193. But the 74 AHC 193 really doesn't exist. They've got a 74 HC, which is a high-speed CMOS 193. That's the counter increment decrement ICs that I use. The HC chip comes in two flavors. One of them is a 24 megahertz, one of them is a 29 megahertz. The costs between them are not significant. And the inputs and outputs appear to match up with the AHC variety, so I believe I'm going to be able to get away with those. If not, that'll be a challenge, and I guess we'll have to figure that out, cross that bridge when we get to it. In the meantime, I get the wiring taken care of for the 8-bit registers. It's pretty straightforward, except I inadvertently copied the main bus in, and it's really the counter output that needs to be the input into the register. So I figure that out pretty quickly and get that corrected. Recall that of the two control signals, I opted to tie pin 1 low and pin 11 to actually control the AND latch signal. So I get those wired up here too. Okay, here's where I realize I actually have the main bus here when I really need the counter IC output. And so rather than having to redo everything again, what I do is I copy the main bus and set it aside so that I can rename each of those inputs and still have the signals I need for the counters. Speaking of counters, let's get those placed and wired up. Now with ground set, let's do the ripple carry so that my carry output and the borrow output both get connected to the count up and count down of the next higher IC. Now, there's no reason for those lines to actually cross over other than the fact that I wasn't really paying attention when I did that. I caught that in editing. Anyway, in the meantime, copy and paste will help me make sure that things get lined up properly. They don't. Missed it by that much. Let me block off a couple of unused output pins, and I got a little click happy here too, so I end up having to sort that out. I end up having to sort that out in a minute too. In the meantime, I can go get my counter inputs and drag them over and turn them into counter outputs so that the outputs of the counters become the inputs into the actual register. There, let's move that one over and clean up that mess. Back to the counter outputs. Now I need to get the control signals for the counters. That's clear, load, increment, and decrement, and bring those down. Well, clear is easy. Load, increment, and decrement actually come off the demultiplexer, and I did not create outputs for those signals, so I have to take care of that as well. Now I can bring those down and actually hook those up to the counter ICs. Now let's deal with the decoupling capacitors. There are 23 integrated circuits on this module, and I need 23 0.1 microfarad capacitors. Plus I want to have a 47 microfarad capacitor across the power coming into the module, into the printed circuit board. So I work on getting those laid out here. Takes a few minutes. Finally, the last order of business here is to change the LEDs off the control signal output to be from active high to active low. And to do that, I have to change the wiring, but I also need to change the resistors to be 1000 ohm resistors. Plus, I need to change the direction of the diodes. So the schematic for the register module is nearly complete in KiCad. I say nearly because there's some sanity checks that I need to go through in order to make sure that I'm actually doing everything right, or I've got everything captured properly, reflecting what's been done on the breadboards. Simple things like counting ICs and decoupling capacitors, double check the inputs and outputs for all the different components that are on the board. I'm going to do those offline, not on video. If I find something, I will come back and record it in the next video. But in the next video, I also want to perform the KiCad electrical rules check, and I expect that that's going to throw a number of errors. So I think I'm going to dedicate the next video to just resolving any problems that KiCad may uncover, and it may be just a matter of decorating components to make sure that it passes rules check properly. We've got to create symbol references, and we'll do that ahead of the rules check. And then I've got to associate footprints with components, and I have a feeling that not all the footprints exist. So there's a library I think I can go grab and bring that into KiCad as well that will have a number of additional components. Now my to-do list continues to grow, and I expect my to-do list to continue to grow for a while. I'm finding more things that I need to do than I'm actually getting accomplished, and that's reasonable with the size of the project that I've got going on. So that said, I still have my clock to-dos. They haven't changed. I'm not going to read them anymore. I still have the opcodes and operations that I need to define, and I still have a line driver I needed to add to the input test harness. Thank you. We'll see you soon.